Good day to you, students. I hope you guys are doing well in your various homes. In our last class, we discussed calculations involving pH and pOH, and that is still under acid-base equilibrium. Today, we are looking at a subtopic under that topic we have been treating, and that is dissociation of water. Dissociation of water. All right. To start with, let us always have this at the back of our mind. Water is said to be amphoteric in nature. And if you make reference to what we have discussed even before you went home on COVID break, we said amphoteric substances are those substances that can act as an acid as well as a base. So if we say water is said to be amphoteric in nature, that means it can act as an acid or as a base. Now, let us now consider a reaction in which 1 mole of water is acting as an acid, while the other 1 mole is acting as a base. Considering the reaction below, when 1 molecule of pure water acts as an acid, while the other molecule acts as a base, the following equilibrium will occur. Now, this is 1 molecule of water. If this one is acting as an acid, then the other 1 molecule is acting as a base. Then what is going to form is a conjugate acid. There is a conjugate acid which is called hydrozonium ion, and this is now a conjugate base, hydrazine ion. Now, from our knowledge of equilibrium constant, if you want to express the equilibrium constant of this equation, equilibrium constant Kc will now be equal to, don't forget, product raised to power number of mole divided by reactant raised to power number of mole. So that will be, the product is, these are the product, H3O plus raised to power, what is the number of mole here? 1. Multiplied by OH, what's the number of mole here? So raised to power 1. Then divided by the reactant. That is H2O times H2O. But don't forget that water is a liquid substance. And I told you categorically that the concentration of water is always equals 1. And the same thing is also applicable to solid substances. So, if that is the case, it means that the concentration of this water you wrote here, this one as well, will be equals to 1. So let's quickly see what is happening here. But since the concentration of liquid is 1, therefore, H2O, that is H2O multiplied by H2O will be equals to 1. So this expression you wrote in the previous page will now be Kc equals H3O plus multiplied by OH minus. You know we are supposed to have H2O times H2O here. But because H2O is equal to 1, that's why we have written 1 here. So anything divided by 1 is that thing. So that's why our Kc equals to H3O plus concentration multiplied by the concentration of hydrazine ion. But take note of this. At 25 degrees Celsius, that is at room temperature, the equilibrium constant of water is always equal to 1 times 10 raised to power minus 14. Always have that at the back of your mind. Therefore, Kc equals to 1 times 10 raised to power minus 14. But don't forget you have said that your Kc is this. So it means our Kc equals to this is also equal to what? This. From this expression, if at equilibrium, that means that out of the 10 raised to power minus 14, H3O will be taking minus 7 there, YOH will also be taking minus 7 at equilibrium. So that is why we have at 25 degrees Celsius, H3O equals to 1 times 10 raised to power minus 7, while OH minus will also be what? 1 times 10 raised to power minus 7. Because this must be shared between the two of them. Alright? Now let's quickly proceed. With the knowledge of equilibrium constant of water, we can easily quickly move into another subtopic under this, which is called strength of an acid. What do we mean by strength of an acid and a base? This is the extent to which an acid or a base dissociate or ionize in water. Now, strength of an acid is the extent of how an acid or base can ionize when dissolved in water. There are we have different types of acid and base with respect to their strength. We have what we call the strong acid, we have the strong base, we have the weak acid, as well as the weak base. Now, what is a strong acid? A strong acid is any acid that ionizes completely in water. Example of a strong acid are, we talk about the sulfuric acid, H2SO4, hydrochloric acid, and your nitric acid, HNO3. Then what about weak acid? These are acids that are partially ionized when they dissolve in water. Example of this is your H2SO3, carbonic acid, H2CO3, and we also have some examples of organic acids like ethanoic acid, your citric acid, your acetic acid, and the likes. Let's look at strong alkali, that is your strong base. It's just the same thing with strong acid. It's just that it is a type of base that ionizes completely in water. What are examples of a strong base? You have sodium hydroxide, we have potassium hydroxide, we also have lithium hydroxide, etc., etc. What about a weak base? A weak base is a type of base that ionizes partially in water. And if you look at this, a major example of a weak base is, that is your ammonia. Okay, we can easily use the dissociation constant or equilibrium constant of an acid to determine the strength of an acid. How do we go about this? Anytime you are dealing with an acid, you call it dissociation constant of acid, Ka. While when you are dealing with a base, you call it dissociation constant of a base, called what? Kb. So anytime your Ka is greater than 1, that means such acid is a strong acid. When your Ka is less than 1, such acid is a weak acid. When your Kb, that is for base now, is greater than 1, it is a strong acid. While when Kb is greater than, is less than 1, in this case now, it is a weak base. Now let's look at this example. State whether an acid which has a dissociation or equilibrium constant of 1 times 10 raised to power 1 times 10, 1.0 times 10 raised to power minus 4 mole per dm3. If you look at this, you discover that this is less than 1. Because if you change this one to decimal number, it will give you 0.000, okay, 160. So this is 1.60 times, if you look at this, this is less than 1. So from here, that means this acid with this dissociation constant is a weak acid. All right? I believe with this little explanation we have made, I've been able to teach you guys things about the dissociation of water and how we can easily use that to find the strength of an acid. This is just a few of an iceberg or among the many more things we are still going to discuss in the class. When we get to the Google Classroom, we'll discuss better than this. As you watch this, I pray God bless you. Thank you.